Okay, we're going to multiply these two complex numbers, 3 plus 4i times 3 minus 4i. And we're going to write our final answer in standard form, where standard form is the form of a plus bi. We're going to use that I squared is negative 1, where I is equal to the square root of negative 1. I'm using the same steps and properties in a lot of times as the steps I would use is if I were instead the imaginary unit, instead if I had I as a variable like x. All right, now the thing is I can see that this becomes 3 squared minus 4i squared. That's just from our formula of a plus b times a minus b. But I have I here. All right. Now when I multiply this out, I have 3 squared minus 4 squared I squared. And I use that I squared is negative 1. And in fact, I'm showing much more than I usually would. And also you might be wondering, well, why didn't I write down 3 squared is 9 and 4 squared is 16? I'm waiting for the very end. Because what I want to show is that if I have this form of a plus bi times a minus bi, if I have this form, which is the form of a complex number multiplied by its conjugate, then what happens? That simplifies to a squared plus b squared. And so in fact, I usually don't really want to show all the steps that I showed here. I don't want to do all that each time. If I know that there's a form and a formula, then I just want to skip to that. So I take a plus bi and multiply by its conjugate, which is a minus bi, and I get a squared plus b squared. Well, why isn't a, well, I showed the work over here. I see that I'll have 3 squared minus 4 squared I squared, but I squared is negative 1. That's why I get 3 squared plus 4 squared, because it's negative 1 times negative 4 squared. So that's why it's plus here. It's not a squared minus b squared. It's a squared plus b squared because of the part that has I. 9 plus 16 is equal to 25, and that's the answer to that. All right, goodbye.